Welcome to the video series on disease causation. In this video, I will be discussing some basic theories that attempt to explain or make inferences regarding disease causation. I start by briefly touching on the older, antiquated theories, then progress on to the more contemporary theories on disease causation. Now, I should kick off this video by describing the basic characteristics of a cause. Naturally, the cause must come before the effect. A cause may include either host or environmental factors, examples of which are listed here. And lastly, we can refer to a cause as either the presence of an exposure or factor that leads to the disease or the absence of such a factor or exposure. In ancient times, disease was mainly believed to be a form of divine retribution for something dreadful a person might have done. Now, primitive physicians back then ventured into some theories involving imbalances in body fluids caused by factors in the air, water, or ground. Now, some even believed that disease was brought about by miasma, a poisonous vapor or mist believed to be made up of particles from decomposing material that could cause disease and could be identified by its foul smell. The miasma theory of disease originated in the Middle Ages and persisted for centuries. During the bubonic plague of 1665, doctors wore masks filled with sweet-smelling flowers to keep out the poisonous miasmas. And because of these miasmas, they sanitized some buildings, required that night soil be removed from public proximity, and had swamps drained to get rid of the bad smells. But of course, many diseases don't have smells, so this theory has become widely disproven as time went by. In 1884, German physician Robert Koch and German bacteriologist Friedrich Loeffler formulated postulates that were based on earlier concepts described by German physician Jakob Henle. Now, this eventually came to be known as the germ theory of disease, or the Henle-Koch postulates, or simply Koch's postulates. Now, these postulates embody the idea of specificity of a cause, meaning there's a one-to-one relationship between an exposure and a disease. Stated differently, only one organism leads to one disease. The postulates included therewith are as follows. A specific organism must always be observed in association with a disease. The organism must be isolated from an infected host and grown in pure culture in the laboratory. When the organism from the pure culture are inoculated into a susceptible host organism, it must cause the same disease. And lastly, the same infectious organism must be re-isolated from that disease organism and grown in pure culture. Now, while this theory of disease has played an important role in microbiology, of course it had its limitations, which Koch was well aware of. At one point, he had to abandon his first postulate after discovering asymptomatic carriers of Vibrio cholerae and Salmonella typhi, bacteria responsible for cholera and typhoid fever respectively. Additionally, viral diseases were not yet discovered when Koch formulated his postulates, and there are many viruses that do not cause illness in all infected individuals. Furthermore, bacteria such as the one causing leprosy cannot be grown in pure media. Now, ultimately, it has become clearer that no disease is caused by a single factor. Thus, more modern theories of disease causation came about. Now, such multiple disease causation models depict the way in which the different environmental and host factors influence the occurrence of disease. Now, the multiple causation models I will be discussing in this video will be the epidemiologic triad and the web of causation. The sufficient component cause model, on the other hand, will be tackled in the next video. While in essence still a traditional model for infectious disease, the epidemiologic triad went further than what was stipulated in Koch's postulates. Now, this triad consists of an external agent, a susceptible host, and an environment that brings the host and agent together. Now, in this model, disease results from the interaction between the agent and the susceptible host in an environment that supports transmission of the agent from a source to the host. Now, the two ways in which this model can be depicted is shown in the figure you see on your screens. The agent originally referred to something infectious. That is, it could be a virus, a bacterium, a parasite, or any other microbial pathogen. Now, generally, the presence of this agent is required for disease to occur. However, presence of that agent alone is not always sufficient to cause disease. Instead, a variety of factors influence whether exposure to an organism will result in disease, including the ability of an organism to infect the host and the size of the inoculum. Now, over time, its concepts have been broadened to include chemical and physical causes of disease or injury, not just infectious microorganisms. The revisions would now include chemical contaminants and physical factors. While the epidemiologic triad serves as a useful model for many diseases, it has proven inadequate for cardiovascular disease, cancer, and other diseases that appear to have multiple contributing causes without a single necessary one. The second component of this triad is the host, which refers to the human who can get the disease. Now, a variety of factors intrinsic to the host, which we know now are called risk factors, can influence an individual's exposure, susceptibility, or response to a causative agent. Now, as a review, such risk factors include intrinsic characteristics such as age and sex, and they also include behaviors such as sexual practices, hygiene, and other personal choices. Susceptibility and the way an individual responds to an agent are also included here, and these are influenced by genetic composition, nutritional and immunologic status, anatomic structure, presence of disease or medications, and psychological makeup. Now, the third member of the triad is the environment, which refers to extrinsic factors that affect the agent and the opportunity for exposure. Now, such factors include physical factors like geology and climate, biologic factors such as insects that act as vectors for infectious agents, and socioeconomic factors like crowding, sanitation, and the availability of health services. The next multiple disease causation model to discuss is the web of causation model, first developed by McMahon, Pugh, and Ibsen in 1960. Now, this model was devised to address chronic non-communicable diseases due to their multifactorial or multi-etiologic nature, though this can be applied to infectious diseases as well. Now, this model again reiterates that there is no single cause of a disease. Instead, it is caused by numerous factors that interact in various pathways. Now, likewise, this model illustrates the interconnectedness of possible causes, as is being depicted in the illustration. Now, such models are important and useful because it represents different pathways that eventually trace back to the root of the disease, thus identifying its causative risk factors. And by the way, the illustration featured here is a model developed by physician and epidemiologist Gary Friedman in 1974 to map the causality of myocardial infarction or heart attack. Now, since gaining popularity in 1960, the web of causation model has since been used in mapping etiologies to a variety of diseases, as well as identifying possible factors for preventive interventions in community health. Now, I will end this video here. In the next video, I will be discussing at length the sufficient component cause model.